Hi, everybody. Are you here for Bazel? Bazel? Are you here for this?
Yes.
Okay. I'm always skeptical. It's such a niche topic that I'm always skeptical that anyone wants to know about it at all, in like a general population. Like at an Angular conference, yes, but in a general conference, could have stumbled in the room. So I'm Kyle Cordes. I work at Oasis Digital. We are one of the sponsors here. If you're interested in Angular, please consider our Angular Bootcamp. But we will definitely not talk about this super advanced stuff in that Angular Bootcamp. So if you want to hear about this, you have to stay here for the next 40 minutes. Tiny bit about me. We teach, we build things. This is the description you were given. The description also talked about building, showing how to do like a multi-language build, but I had to cut that for time because I needed the full hour to do that. It turns out we're only supposed to take about 45 minutes max. So we're going to do a lot of talk about Bazel and how you can build Angular, but we're not going to talk about how to use it to build Java. So if you're here for that, sorry. So first, a little bit about Angular. Raise your hand here if you're using Angular. I see people I work with in the back row raising their So Angular has a lot of competition. Raise your hand if you're using React. Okay. Anybody, any Vue people? Anybody not of those big three building web stuff? Okay, so just a small number. Angular's strength, kind of the point of caring about Angular, is because you're using it to build stuff in the enterprise. If you're just building a little bitty standalone thing, I mean, Angular is great. It has like really good optimization to build little things, but there's really no reason to pick Angular over the competition if you're building little things, because React is great for little things, and Vue is great for little things, and Stencil is great. I mean, there's anything can be used to build little things. Angular's real key target is that it has tools to manage, vast sprawling complexity. And that's actually where it's been most successful. At work, yeah, you asking a question?
How big are we talking? Are we talking like an HR application?
Google uses it to build incredibly sprawling things. I don't know if they've actually released the numbers, but the numbers are very large. Like million lines of code, maybe? Okay, so keeping in mind this context, you run into a problem. Building them is slow. Now, there's multiple meanings, right? Like literally coding them takes a long time, and the talk about that is probably more important than this talk, but I'm not giving it today. I probably should give that talk. The problem I'm talking about today is that literally compiling big Angular applications is slow. And that's actually not specific to Angular. Compiling big applications is slow, regardless of your platform. Again, large applications is slow. Now, that matters because developer time is expensive. Developers waiting to see the effect of a change they made, right? That costing time. Well, developers are in short supply and cost a lot of money. Now, you might think, this is only a problem if you're paying, right? If you're paying for the work to be done, building large applications slowly is expensive because it's costing you time for the waiting. But I would argue it's actually too expensive. Building big things slowly is too expensive, even if you're being paid to do it, which probably all of us here are, because it's miserable and demotivating. Making a little change, and then going and like playing for a while it recompiles. I mean, that's fun. It makes a cool XKCD, but it's like a really miserable job to like have every incremental change you make have a long wait to see if it fixed the problem that you're working on. So the Google folks who have a whole lot of experience building huge things with big teams over a long time, they think, let me see here, a couple of seconds is the key bit in here. I probably should have bolded it. But they think that to be really good enough, to have a really fluid, like to kind of optimize the brain power of the human operating the computer, you really want there to be a 2-second latency from saving an edit in your editor to that new code running in front of you. Now, that's a pretty high bar. Now, as a high bar, though, who thinks it's a high bar in category 1? That's having a big app, a small change be running in 1 second is just crazy. Anybody willing to say that that's crazy? Okay, we got several people who agree it's crazy. Who thinks that this is a problem we should be able to figure out? You know, we can put a man on the moon. We ought to be able to figure out how to like make a small change and recompile in 2 seconds. Who thinks that? Why?
Maybe 5 seconds.
How many operations can the CPU in your cell phone do in 5 seconds?
A lot.
Like 5 billion? Yeah. So yeah, it should be possible. If we were smart enough, it should be possible, is the answer. So Angular has solutions to deal with size. So raise your hand if you're familiar with ng modules. Raise your hand if you do not like ng modules. So ng modules, the point of ng modules is to enable separate compilation. So any C people in the room? Give me a C. Very, very small subset of C. The chunks of code in your Angular app that you put in a different module can be compiled separately, much like you could do like with compiling C source files separately in the bad old days, or even Modula 2. I'm not even going to ask for a show of hands on Modula 2. I'm going to assume it's 0. So roughly speaking, the code in one module in Angular, it depends only on the metadata from all the other modules in the application. It doesn't depend on the actual lines of code in there, but only on like certain pieces of data that are emitted during compilation. So you technically should only have to recompile the one module you edited and then like kind of relink, like rebundle, reconnect the application back together. So unlimited size, no matter how big your application, if you make an edit to a single module, the cost of that, the time of that should be the time to compile one module, which should be very fast, because if you're doing a good job writing modular code, your modules are probably not huge, right? If your modules are not huge, compiling one module is going to happen real quick. And then if you can find a way to make that process of linking them back up together fast, then in theory, we should be getting to that 2-second latency that Google thinks is heading our way. I'd like to point out that everything old is new again, and for the right hardware with the right build system, there were people that had this 2-second latency 10 or even 20 years ago, depending on the language library and tooling they were using. So this is definitely achievable. It has been achieved before. It can be achieved in Angular. Okay, so omitting a lot of the complexity, this is what the process of building an Angular application looks like. You've got some ng modules, so you've got more than one of them here. You run through this tool called ngc. Has anybody ever ran, raise your hand if you ever ran the ngc command by hand? 2, okay, great. So roughly speaking, ngc takes all the junk that's in an ng module, gets some help from tools like Sass to deal with the Sass in there if you're using it and so on, and then produces some bundle of code that represents that module, right? And then those modules get bundled together, right? Or maybe even split apart for lazy loading. They get optimized in some way and they get shoved into a browser. So like this is a highly abstracted notion of what an Angular build pipeline looks like. The mainstream way to achieve that build pipeline is with Angular CLI. Angular CLI is a bunch of really, I guess, hard-earned quality that they've been working on really hard for a long time, wrapping around Webpack, which also has hard-earned quality. It's really the state of the art. So if you just want to like pick up some tooling and have it work without thinking about it, you should like run out the door now. Don't think about Bazel anymore. Do Angular CLI. So this is a great piece of technology. It's kind of conceptually in the Angular box. It actually has a code provenance problem in that it depends on a lot of code that comes from the broader NPM ecosystem. So there are companies that get nervous about it because they're bringing in 300 transitive dependencies. But conceptually, at least, in terms of like responsibility for like managing bugs and so on, Angular CLI, it comes from the Google team and so on. So you probably should be using it instead of the crazy stuff that I'm going to keep talking about next. But it's important to keep in mind it basically consists of ngc, which a couple of us has run by hand, Webpack, which probably all of us have used either directly or indirectly, and a whole bunch of glue code that bails them all together and makes them work. Okay, so there's really not a lot wrong with Angular CLI. At work, we use Angular CLI for I think 100% of the like real commercial projects we work on in Angular. So I want to show of hands who's using Angular CLI on a project, And is there anybody who has a real project that's not using Angular CLI? I'm looking at Corey because he's the one I think is most likely to go down a crazy path with me. Okay, so CLI works great for most cases. It keeps getting better. It does have 1,000 open issues, but it also has like a team of smart people that are like, slowly eating away at those issues. It has some rough edges. Most of those rough edges are because the underlying tools have rough edges. So, for example, I've heard that earlier today someone had an oops in a presentation in this room where they accidentally got one import wrong in one source file of their Angular application. And that one strange import caused the whole application to not build with a highly obtuse error. And that sort of thing, that's the sort of rough edge I mean with Angular CLI. But still, it's the right answer for pretty much everything. The only problem is if your project is large, you're not going to be anywhere near a 2-second turnaround for a small edit if your project gets large. Okay, so Google's effort to work on making this good is called ABC. I take umbrage with this because we have a class called Angular Bootcamp that we call ABC, so I'm a little bit irritated that they have a thing called ABC. But I guess they win, it's their product. It used to stand for Angular, Bazel, and Closure. But we'll talk about the Closure in a minute. It's kind of fallen to the wayside for now. So now they made it stand for Angular, Build Tool, Convergence. The convergence means they want those of us outside of Google to be able to use similar or the same tools that they use inside of Google. So convergence between how they do their Angular apps and how we do Angular apps. So of those two main tools, Bazel is about fast, scalable development, and Closure is about making the smallest possible asset size. But it turned out that a whole lot of people care about the thing on the left, but big projects don't really care that much about that last couple % of optimization you can get from Closure. And more importantly, this Ivy effort that's underway, that I don't think, did anybody talk about Ivy today? Okay. This Ivy effort, it's like a different effort at Google to make Closure, or to make Angular faster and better in 5 different ways. It's actually going to make a much bigger difference than Closure was anyway. So this Closure thing, we're just not going to talk about that anymore. What matters is Bazel. So the goal is that 2 seconds. This new tool stack, which is what we're going to look at, what we are looking at here, this is how they build Angular itself. So the Angular that we get and download and use via NPM and all that machinery is actually built using this machinery. So internally, they're already on this machinery or some proprietary variation thereof. They're talking about this ABC effort, including many new kinds of really great tooling. I think they'd be very welcome. Many of us who've been developing for a while really appreciate some of the tools we have for like .NET or like Java. Really, really nice dev tools. I'm hoping more of that stuff arrives here in the Angular world. But the part we're zooming in on here is Bazel. Now, that Blaze there, that's not a misspelling. Google has an internal tool called Blaze. And I believe they just tried to find other things that were close to English words by rearranging the letters to make an open source version. They can't open source their internal version because apparently it's like wired up to all their internal proprietary machinery. So they have a bunch of internal stuff about how they do source control, and their Blaze tool is just littered throughout with connections to that machinery. And so they have this effort to build this sort of parallel extracted open source thing for the rest of us to be able to use. But Google uses this to build everything. They've been doing so for like 10 years as of a few years ago. So this is like not a new idea at all inside Google. And furthermore, people that have left Google went to Facebook and they like re-implemented basically the same idea with a tool called Buck. I don't know if anyone's ever heard of Buck, but that's yet another build tool. It's a whole lot like this. The syntax is a little different to make it not violate something. The code looks like Python, but it works like make. Did I hear a question? No? Okay. Okay, so that's its website if anyone just wants to go look at it. I kind of like their little tagline, fast, correct, choose two. Kind of clever. Okay, so I just borrowed a chunk of a slide from a guy named Alex Eagle. He works at Google. He is the person primarily working on this Angular plus Bazel machinery, and he goes over all these like key aspects about it. So just going through them in order here. So incremental, that's the idea of if only one line of your code changes. So you make a one character edit, you press save. That change has been contained inside one ng module because an Angular application is made of many ng modules. And so we want to incrementally rebuild just the part you changed so that the rebuild time is proportional to how much you change. So if I change one tiny piece of my program, I want to have just a real little bit of work happen to get the new program running. I want it to be deterministic means that if I compile a program and you compile the same program, you compile the same program, we get like a bit identical output from that compilation. Because if you can achieve that, you can do this really slick caching, where if I compile an incremental version, it like takes the build output and it shoves it over on a server somewhere, and then you need that, it skips compiling it for you and just grabs the output there. So basically, if these things are done just right, instead of each of us using our machines to redo all the work of everybody else, like we're all sharing the effort of rebuilding the software as it evolves. So there's huge payoffs to that determinism. The Hermetic kind of goes with the determinism. Composable means Bazel plugins work like Unix pipes. So any Unix pipe fans here? I love Unix pipes. So they kind of conceptually fit together like that. And I'll skip the rest of the bits of this. Actually, there's one bit I should say. This stuff is farther along for Androids. I think there's actually a bigger community of people already using all this today that are building on Android than there are on, like, Angular. Hardly anybody's using it, but Android, quite a few are. Okay, so there is a happy path for these tools, and that is you're using some build rules that somebody else set up. You've already installed the thing for project 1. You pick up project 2, and you just type a single command, and it gets all your tools and puts them in and gets it running, and you're up and running. So the happy path for this stuff is really fantastic. Now, some people have taken issue with Java being part of the happy path because Bazel is actually built in Java. It's a Java program. So for those of us who have been around a while, that's a good thing because Java is super boring and robust and it just sort of works without much thought. There are some who have arrived on the scene in the JavaScript era are like, well, why would I soil my computer with this obsolete Java? I say, it'll be okay. It's not going to hurt you. It just works. Okay, now we're going to try to stay at a pretty high level here. I will walk through examples of these files a little bit, but roughly speaking, to configure a build, you need one workspace file. So basically for an entire group of related projects, you have some workspace file that kind of defines the kind of project level build properties, somewhat like a package JSON. And then for each separately compiled chunk of an application, you have a file called build or build.bazel. You can name it either one. Right now, you have to code those build files by hand in most cases, which is quite unpleasant. And that's why this stuff's not very mature yet. When it's mature, those will be generated for you, but still, we can get up and running and see how they work. And then Bazel is a very programmable build tool, and the way you teach it to do a new kind of build is with one of these BZL files, and those are generally written by somebody else. So a BZL file is analogous to Angular CLI, right? Go ahead.
So I think the previous slide you mentioned, can you move this previous slide? Some rules, right? You mentioned some rules.
Yes, Bazel rules are these BZL files.
Okay, so I have a question. So in the React, before you make a build, we have some rules like a linkers. You have to follow those rules.
Sure.
If it is violated, then it's not going to build. Is that some similar wording?
Yeah. So a Bazel build file can specify what kinds of rule logic to pick up and apply. So you could make a BZL file, or you could find some existing BZL file that defined how linting worked, and then in your build file, you'd say, apply linting to this unit of compilation. Right? And so a BZL file is like Angular CLI, or like a lint tool, or so on. Right? So it's a tool that generally, as a developer, you just consume. You just pick up and use from somewhere. Whereas an application only needs these first two kinds of files. So this thing is, although what we see in a few minutes is a bit verbose because it's typed by hand, fundamentally, it is designed to be very, very scalable, right? So if your application has 1,000 separately compiled modules, each of those would have one build file, and you'd have one workspace file at the top of the whole thing. And so it's made to scale quite nicely in terms of there being not very many pieces moving around relative to the size of your app. Okay. Now, we're not going to do this, but Bazel is suitable for going big. If you're willing to do some extra config work, you can do things like have an extra machine or an extra cloud full of machines that your computer can delegate build work to, right? So if you need to do a rebuild of some massive piece of application, rather than it churning through on your local machine, there's ways to like have a cluster of machines help you rebuild all the pieces in parallel, which is super slick. Then this caching interim results that I mentioned earlier. So I could be delegating some work to a build farm, and I could be caching the results so that when you need the next build, you wouldn't even be delegating, you'd just be grabbing the results. So this thing is made to really produce great results when used by a team at scale. It relies on well-defined inputs and outputs, which is kind of a sticking point. In order to be able to do that kind of automation and shareability, you need to not have every tool you run potentially depend on every file on your computer. Because if you think about it, if you write a program right now, you could write a program, you could call that program a compiler, right? You could use it to compile your code, but you could write a program that didn't only look at your source files, you could make it read all the other files on your hard drive. And that would be bad, right? Because that means that if I compiled the same thing, I'd get a different result. So this notion of having well-defined contained inputs and outputs, this is really the sticking point of why it's not trivial to take just any existing tool like compiler and just shove it into this Bazel or Buck or whatever ecosystem, is because many of those tools are written very sloppily with very little consideration for having tight control over what files they consider input and what files they consider output. So that's why, that's probably the number one reason why it's taking so long to get to a world where tooling like this is just available to all of us trivially all the time. Because there's a lot of legacy out there that has to be worked through, especially around this hermicity around well-defined inputs and outputs. Okay, so where is this thing today? I would say it's robust because its predecessor has been around at Google for 10 plus years in very serious use. I would say it's still in development because I'm on version 0.21. I think last year I was on like version 0.15 or so. And you'll note that these things start with a 0, not with a 1. So for some reason, they have not declared it 1.0 yet. So it's also still in development. There are rules, and you will hit rough edges. So anybody, like, if you're happy with CLI, stay away. Because this is for people that have problems that are not solved with CLI, who are willing to fight rough edges. It relies on Java, and it runs on Java. So it's actually, I think, probably really better fit for Java than probably for really any other platform, because you kind of are already embracing the ecosystem it runs on that you're building for. There have been, like, if you read the changelog for Angular 6 and 7, it's sort of peppered with Bazel-related improvements, right? So is there anybody else than me that like reads the changelog every couple months? The same two people answer all these. So the reason why that is that this tooling is in heavy real use at Google. So they keep making improvements because Google probably is the biggest user of Angular. Okay, so the biggest caveat is that approximately 0 non-Google libraries have a Bazel build setup already in them, right? Now, I'm sure it's not 0. There's probably a few, but it's close to 0. So whenever your code touches third-party libraries, you will have to do a bit of extra work if you're using this stuff. Igor Minar is one of the key people on the Angular team. Here is his tweet from, I believe, today. Is that right, Lance? So this is a very fresh tweet. It's a couple hours old. His statement of the present and future of this tool. So if he's in charge of a lot of the stuff and he's calling it experimental and unoptimized with lots of issues, like I'm not going on a limb to say this is for people who really, really want to work with it. But I actually share his opinion. There's a huge amount of potential here to produce some great results over time as issues get worked out. So kind of hitting some of the things you just said. If you have really strong needs to handle big things, you can get there. And then this last one, I didn't really understand this last one really well until like the last 6 months. And that is, if you're building with Webpack, with Angular CLI, and so on, you're actually taking a dependency and you're bringing in a lot of code from the NPM community. And like, that's kind of okay with me because it has to be okay with me. Because like in the front end work where I make a living, like you just have to like be like, sure, whatever. Just like shovel in the code from NPM. You know, what can you do about it? But there are companies who have like strict regulatory requirements, or just like they're prone to worry a lot, right? And they actually care a lot about the provenance of all the code that they're either using to build their product or shipping in their product. And so it is plausible that there are projects that should use this tool stack, because if you use this tool stack, you can build an Angular app, bundle it, ship it, without using hardly anything from NPM. Which is certainly not true for Angular CLI or for any other stack. So there's got to be somebody out there who has some really strict governance requirement that's like just super concerned about the 300 transitive dependencies that you pull in when you install Angular CLI, and you could deal with that by going down this route if you really need to. Okay, I wanted to point out this little bit for anyone that feels like trying it at home. There's some kind of schism or dispute. The Mac Brew package manager, which I see a Mac, I know a couple of Mac people here. Mac Brew is great, but for some reason the Mac Brew folks are not cooperating with some aspect of the very latest Bazel, and so you now have to do this tap mechanism to like add this other source of packages for Brew to get the latest. Otherwise, you get a couple versions back. So it's just kind of yet another wrinkle of oddity. Okay, I'm going to skip this slide because it is too far down in the weeds. But if anybody is really interested in stress testing their Angular build tooling, please come talk to me, and I'll talk to you about stress testing your Angular build tooling. I have a bit of a demo. The demo, all it does is it runs a program, and you can see that the program ran, and then I edit a line of code. So I think it's going to go well, but it might go more like this. So, okay, before I click the button on the demo, any questions so far? Okay. So the demo I am running, I have intentionally chosen to just run the official Angular team provided Angular Bazel example. And this is where I had been thinking of building my own more complex, subtle example with some more things in it, but that seemed probably unwarranted for the situation at hand. And so I said, if I just stick what's in the box, then anyone here who's actually curious should be able to pull this down, type yarn serve, and it should all stand up and run. And we're going to see that work in a minute. So you can trust me that I typed yarn before we got here, because it took a while, to pull in some various things. Because this project uses Angular CLI and Bazel. And in fact, it uses NPM to install Bazel, which is a kind of interesting little backwards trick. But so this one takes a while. And I also ran yarn serve, which fires up Bazel before we got here, so that I would have pre-cached a bunch of stuff, so we don't have I think it took like 6 minutes the first time I ran it. Bazel has a really interesting view of the world. Its view of the world is not to trust binaries that are provided by outside sources. This takes a source dependency. So if you point this thing and say I'm using Angular, it actually compiles Angular as the first time you go through. And it works great. But you kind of need that caching thing to get good results. So anyway, so I can just run this, just the serving part at any time. And because I've already done this once, it will not be a horrendous effort to get up and running. So here we are up and running. And the reason that was so fast is because nothing had changed since last time I did this. So here's a little program. And this is just their example program. But just to illustrate what can be done here, I'm going to make a small change and see how fast that change takes effect. So I think it's in this hello world component. So here's a really small change, right? So if I save that, now unfortunately for Chromebook related reasons, I'm running this on a Chromebook, the thing that triggers page reload is broken. That's really irritating. It has to do with how the Chrome development container works, but it doesn't matter. This thing here will tell us how long it took. So on a cold start, so the first time I did this, it took 8 seconds to make such a change. And somebody said something?
That's pretty good.
Yeah. Okay, let's check the second. So that's the second change, another trivial change. This time it took 3.4 seconds, right? Not too bad. On my real computer, on my Mac, it actually takes about 2 seconds for this incremental change. This is a Chromebook Pixel. Is there any Chromebook users in here at all? All the interesting questions. It's just YouTube. So Chromebooks now have a way of running a Linux container in a window on your Chromebook. And so you can actually do real, like, arbitrary software development in this sort of safe sandbox on a Chromebook, and that's what I've been doing. But this is like the cheap model. It's like the i5 model. I don't use it that much, so I didn't get the i7 whatever core one. But still, that's not bad. And what I don't know is whether it keeps getting better. I haven't gone back and forth enough times, but in theory. Oh, look at that. So on my third change, it's 2. So I guess my cache is getting warm. So if I keep making more changes, it would eventually, I don't know, might hit the 2-second mark. And I'll just demonstrate that it really is serving the different code, right? And if I didn't have this oddity with how the container connects to the browser, then it would have live reloaded as I did that. But there's kind of a rough edge there. Okay, so the last thing I have to do is just point out a few of the details inside these setup files. And I'm going to skip most of them because they're full of details that only matter if you're really deep into it, but there are a few bits worth talking about. So this is that Workspace level file. And all it's doing is it's telling the tool, so telling Bazel, about where to go get rules that I need. So there we go. It's saying, go get me some TypeScript stuff, some Sass stuff, some Angular stuff, and some Angular material stuff. Apparently there's some custom build tooling because of the way Angular material builds it's used. And that means, by the way, the first time I typed yarn serve on this machine, it got and compiled Angular and it got and compiled Angular material all into its local cache. That's just how this world works. So this file, as I was saying, there's not much to it. The interesting thing is just each individual build file. So let's look at one of them. So here's the build file for this hello world. So the little part of this screen that represents the hello world route, I think it's just this part right here. So let's take a look here. So Bazel is not Angular specific. It's not JavaScript specific. It's not TypeScript specific. It's not Mac. It's not Windows. It's not 2019 specific. It'll build anything anyhow. And the downside of that is when you talk to it, you have to go tell it where to get the stuff to do what you need to do. And so there are some annoying bits here. Like I had to go tell it that I want to do an ng module compilation, and I had to tell it to go get the code to do that out of Angular. So at Angular is like a local alias for the Angular code that's been pulled in, and the Angular code includes a Bazel build rule. And so I'm telling it, go get the rule that shipped with Angular that knows how to compile ng modules and make that available to me here. So basically line 1 is an import for people who write Angular code. Yeah.
So this is already there, determined, you just pulled it down.
Yes. The downside is, so the example I pulled down, somebody handcrafted this file.
First time or whatever.
Right.
Did it.
As the tooling progresses, right? So I said the status, it's very much in development. Eventually, this file will be automatically generated for you as part of the tooling. But for the moment, if you have that use case where you need this tool today, you find ways to either generate or hand code these files. I did an earlier talk similar to this. You go watch on video if you want. On that one, I was pursuing a different direction, and I actually wrote a little tool that automatically generated one of these for each module, and I could tell it to generate 1,000 modules. So on that one, I actually went through and had it automatically generate a huge number of modules,
Very cool.
Here's another component in the compilation. But this time I decided it'd be better to actually talk through the meaning a little more instead of just being like, whiz bang, it did a thing. Okay, so we're using Sass. So here we are telling it how to build our Sass. We gave it a name for a build rule, that hello world styles. We told it what the source of the Sass is, and we told what it depends on. So we said, hey, there are some shared styles out there, and we depend on those. So, I know. So by telling Bazel about the dependencies between modules, it knows that if the shared styles change, it has to recompile this module. So that's kind of that dependency wiring we mentioned a little bit earlier. And then this is actually the very last bit here is, this is how you tell Bazel about your ng module. And so I was pointing out, ideally this would be automatically generated. If you just look at the lines in here, you can imagine, like just as a human, like looking at your directory of code for your Angular codes module, and like pulling some bits out and typing them in and making this like kind of mechanically. And that's why I said this is definitely an automatable process. It's just not automated yet.
Like Angular CLI, JSON.
Angular CLI could definitely, now there's actually nascent Angular CLI Bazel support, but it doesn't automatically generate these files yet. It's very much in progress.
It has something similar like Angular CLI JSON, right?
Yes. You can actually think of this as being analogous to like one chunk of your Angular CLI JSON. Okay, so this was actually my target, to get you to this little chunk of code so that those who have used Angular could see how this is kind of analogous to what you're already doing. So I think we're almost out of time, but I will take questions until somebody tells me I have to stop. Yeah.
Can you also use this to build your test stuff? So when you build
This
test,
is
it's a module for every single.
super generic. Yes. You can absolutely.
Because I feel like testing, when you resave that and it recompile, takes way longer than live reload. And it's because it makes a module for every component, right?
So you can, and Google does, for those who work inside the Googleplex,
Sure.
declare all the dependencies all the way down, all the way across. So when I edit one line of code, it finds all the code across Google using this mechanism that might be affected by that line of code, recompiles it all, recompiles all the tests, reruns all the tests, and tells me if my one character edit in this little piece of code here, what it broke across their whole ecosystem of code. So this is really going big in terms of capability.
What do those BZL files look like? Are they kind of similar to this? Or?
Let me see if I can get one. I don't think I have any in here. If you go to that Bazel build site, you'll see examples. They look kind of like they look like Python code, but they don't have the same meaning as Python code. How's our time? When are we supposed to?
5 minutes.
We can talk to her. I don't want to be the person who goes late. Okay, I'll take a couple more questions. Go ahead. Anybody? Corey, you've got to have a question.
Sure. I'm interested in what's your definition of a big Angular application? Like in magnitude of 10,000 plus lines, 100,000 plus lines. Like at what point does a team look at their code base and say,
So
I might want to look
I
at
don't
this?
I don't know if there's anything official. There have been rumors that Google has applications on the order of 50,000 source files. I don't know if they've ever like said officially that they do. So I would say my definition is like 10,000 source files or more. Because if I've run a little generator to make programs that have that many files, and I got to tell you, it gets bad. Your IDE falls over completely.
That's crazy.
Yeah.
Files.
Yeah, but like, I mean, there's companies that have like floors of buildings full of developers who are all like jointly building little bits and pieces of a big sprawling app. And if you have 200 very productive developers working for several years, you can get a lot of source files. Yeah.
Do you know, so if we have to build these Bazel files throughout dependencies here, which is already defined in the import statement, so how likely is it that that file can be totally auto-generated by a CLI?
I believe that it is possible to essentially completely auto-generate these. Like, for example, you could have code that consumes your TypeScript for a certain module and looks at what it imports and only imports the parts of Angular that your code actually needs. Absolutely. You wouldn't want to just make it depend on, you really don't want all the code to depend on all the dependencies, because that means if one dependency changes, you got to recompile all the code. You really want it to like look at your code and automatically craft the exact set of dependencies for your actual code. I should take one more question, because I am a person who stops on time, yeah.
So ultimately, yes, this would save compile time, but the amount of time it takes to make all this stuff, what's the cost of rate of return?
I think they're obviously high rate of return because all of the really big companies who manage really big code bases in this kind of automated CI way have all implemented or reinvented or adopted some form of this. That's why Bazel and Buck, those even aren't the only two. There are actually many kind of competing build systems trying to solve this problem of building at scale, and they all have this approximate similar shape. So I'd say if your project is big enough, there's no question it pays off. Okay, that should be the last question, so we stop on time. So thanks for coming. Hope you enjoyed it.